Physics students, good afternoon. In this video today, we're going to be looking at what we've covered this on Unit 6 with energy and springs. In this video specifically, we're going to be looking at the kinetic energy of two different objects, and how those two compare to one another. So, this is specifically problem number 7 on homework assignment number 8, which we're going to be dealing with two different objects and kind of comparing their kinetic energies. So, question says this. A 7.27 kilogram bowling ball moves at 3.21 meters per second. How fast must a 2.55 gram ping pong ball move so that the two balls have the same kinetic energy? Okay? So just for kind of a sense of scale, we have a bowling ball, a pretty large mass, and then we also are told we're dealing with a ping pong ball in this problem as well. So ping pong ball, a bowling ball. These are what we're dealing with here. I'm going to set them aside. We'll come back to them in just a moment. Okay, so the problem asks this. How fast must the ping pong ball be moving so that the two balls have the same kinetic energy? So here, we're dealing with the kinetic energy of these objects, which is their energy of motion. So kinetic energy, regardless of what type of object we're dealing with, is equal to the product of 1/2 times mass times velocity squared. Okay? Now, before we get into actually solving this problem, here's what I want us to understand. We're told the bowling ball is moving at 3.21 meters per second, so roughly about 8 or 9 miles an hour. Now, that bowling ball is moving toward my face, regardless of how fast it's going, even if it's only 8 or 9 miles an hour, I'm going to get out of the way. The reason why is that if I don't, that bowling ball is probably going to hit my face and most likely break my nose. It has a large mass, and regardless of its velocity, it's going to hurt. It's going to do some damage. It has some energy in that object that's going to cause my face to experience something unpleasant, if you will. Now, we're asked in this question to find out how fast the ping pong ball needs to be going in order to have the same amount of energy. So, you're probably wondering, well, if it has the same amount of energy, that means it's going to have the same effect when it hits me, right? Meaning that the ping pong ball, in order to break my nose and cause the same damage as the bowling ball, would need to be going much faster. If this is going 8 to 10 miles an hour, I might turn away, but I'm not going to be terrified like I would of the bowling ball. Okay? So in order for this ping pong ball to break my nose, it needs to be going very fast. So the number we're going to get for this velocity is going to be pretty high. So here's what we're going to do. We're going to set our two equations for kinetic energy equal. So we have the bowling ball and we have the ping pong ball. And we're told we want those kinetic energy values to be equal. So our kinetic energy for the bowling ball is 1/2. I'm going to call this mass of B for bowling ball times velocity of B, bowling ball squared. And in this scenario, we're told we want those kinetic energies to be equal. So that would be equal to 1/2 times the mass of P for the ping pong ball times the velocity P of the ping pong ball squared. And what we're going to do is we're going to set these equations equal because the question is telling us we want their kinetic energies to be the same, meaning the kinetic energy of the bowling ball has to be the same as the kinetic energy for the ping pong ball. Now, anytime we set equations equal to one another, we want to pay attention to see if there's anything we can cancel out, anything that appears in the same form on both sides. Okay? Now, just because we see a mass and a velocity on both sides does not mean we can cancel them out. Because on the left side, that is a mass and velocity of the bowling ball, and on the right side, that is a mass and velocity of the ping pong ball. So even though they're the same variable, that variable is being applied to two different objects, so we can't cancel them out. But one thing we can do is because we have 1/2 on both sides, we can cancel that out. We could also multiply by 2 and get rid of it. So if we kind of multiply everything by 2, that will simplify our equation down to this. Mass of the bowling ball, velocity of the bowling ball squared is equal to mass of the ping pong ball times velocity of the ping pong ball squared. Now in the problem statement, we're given all the information relative to the bowling ball. And we're even told the mass of the ping pong ball. So really, all we need to do is find an equation where we can get the velocity of that ping pong ball by itself. So what I would do is I would divide this right-hand side of my equation by the mass of the ping pong ball. This value on the right-hand side will thus cancel out. And then all I'll be left with, I'll rewrite this just so it looks a little bit cleaner. Velocity of the ping pong ball squared, is that I want to take a square root of both sides of my equation. Okay? So the square root of a quantity squared, well, that will cancel out, and we'll be left with an equation that looks like this. The velocity of our ping pong ball is the square root of mass of the bowling ball, velocity of the bowling ball squared, divided by the mass of the ping pong ball. Now remember, we're probably going to get a pretty high value here because in order for that ping pong ball to cause the same amount of damage, it has to be going really fast. So I'm now going to plug in all of my variables. So velocity of the ping pong ball is equal to the square root of, well, mass of our bowling ball, which I was told was 7.27 kilograms, times, well, the velocity of the bowling ball squared. My value is 3.21 meters per second squared. And then I'm going to divide by the mass of the ping pong ball. Now be careful, that value is given to you, to us in grams, meaning it's not in the unit that we need it to be in. So what we need is to convert that value to kilograms. So we can divide 2.55, or whatever your value is, by 1,000, or move our decimal 3 places to the left. So it would be 0.0025 kilograms. Some of you might notice it doesn't really matter in this scenario what units our mass are in, because as long as they're the same on top and bottom, we're going to get the right units for velocity. Now that's not usually true when we're dealing with the energy equations, but here it's not really that important because of what we're looking for here, a velocity, not necessarily an energy value. So I'll go ahead and plug these values in. 7.27 times 3.21 squared divided by 0.00255. I'm sorry, there should be one more 5 there. My mass was 2.55 for the ping pong ball. So that's going to be a very high number, and then I won't forget to take a square root of that very high number. When I do, that gives me a velocity of the ping pong ball of about 171.4 meters per second. Now again, you're going to get a value, just as I did here, that was pretty large. So for me, 141.7 meters per second, to put that in context, it's over 350 miles an hour. But remember, we want the kinetic energy to be the same, meaning the bowling ball would hit me and have the same effect as the ping pong ball. And so the ping pong ball obviously needs to be going much faster in order to cause the same damage or to have the same amount of energy. So here's how we would go through and approach this type of problem. We set the kinetic energies of each ball equal to one another, and then we use those to find the velocity of our smaller ball. So hopefully this gets you going in the right direction for question 7. Pay close attention to the units that you're given and make sure that we're setting up the equation properly to solve for the variable that we need. Good luck.